Lesson 2.5, Similar Figures. Our goal today is to understand what makes figures similar, just like we discussed in class. Now, before we go any further, don't forget, some of these notes you've already put in. In fact, a lot of them look similar to what you've already accomplished in class, but it's good to watch the video just to see does your definitions and your understanding match up with what you wrote down in your notes. All right, so let's take a look at question 1, which was in the conclusion to the activity we did in class. So their definition, and again, you might have put it in your own words, is that when it comes down to it, similar figures means that we're looking at figures that have the same shape, like these two down here, the exact same shape, but not the same size. And so that's how similar is different from congruent. With congruent figures, the figures would have to be the same shape and the same size. But with similar figures, same size is not a requirement. All right, the next thing is, well then, what are corresponding angles if they're not the exact same shape? Well, with corresponding angles, it's just like before. They're the matching angles. A matches with D, B matches with E, C matches with F. And even though they're similar and not congruent triangles, that it does turn out that those angles are congruent to each other. And it's a little hard to see on the screen, but that's the congruency symbol, the equal sign with the little squiggle on top. So A is the same angle measure as D, B is congruent to E, C is congruent to F. Now what has changed though, since the sizes don't have to be the same, that with corresponding sides, well, corresponding sides still means matching sides, so side AB here would match with side DE, and so on and so forth. But with similar figures, they're not the same, but we do get equal ratios, that if we match up the sides and form ratios out of them, like AB and DE, that ratio is equal to AC over DF. And here's what I mean. So if I take the side lengths, AB, and put it over DE, well, it turns out that that fraction, that ratio, turns out to be the same as BC and EF. And it turns out to be the same as the last one, AC over DF. And in fact, this is what we call the scale factor. It's telling us how much bigger or larger that this shape is compared to the original. All right, so the way we indicate that shapes are similar is with this symbol right here. It's just the little squiggle line. No equal sign, just the squiggle. So this says that triangle ABC is similar to DEF. And notice how this is different from congruent. All right, so like I was talking about before, scale factor, which is again is something you might have put in your notes, is that ratio that we were trying for also tells us how much bigger or larger the shapes are compared to each other. Okay, so for example, and this will be a little hard to do because I don't have a stylus with me right now, but let's say this had a length of 3, AB, and DE, its matching side, had a length of 4. All right, well, what I would do is I would set up this ratio. And here's where you have to be a little bit careful. It's always the image. Let's say this was the original shape and it got blown up to this size. The new one goes first. So the length of 4 gets recorded first over the pre-image original, which was 3. So I get a ratio of 4 to 3, or 4/3, meaning that this shape, all the lengths are 4/3 times as big as this one. Or if it makes more sense to you to think of it as a mixed number, all the measurements on the second triangle are 1 1/3 times bigger than the ones on the original triangle. All right, so number 2 is list 3 things you learned about similar figures. Now, that's going to be a little bit different for everybody in your notes, so we'll just skip that. But we're going to go to number 3 and number 4, which were 2 example problems that you were supposed to try out. So let's see how you did on those. All right, so let's take a look at our work for number 3. The following figures are similar. Fill in the lengths of the sides for the second figure if the scale factor is 3/4. All right, so what we want to do is we basically want to take each side and figure out, well, how much did it shrink by? Because obviously by the picture we can tell this is reduction. I think the best way to start, let's call this side X. If I want to find X, what I want to do is I want to set up a ratio with X and its corresponding side. Now don't forget, it has to be the image over the pre-image, or the original, the new measurement over the original. So what I'll do is X over 2. Okay, that's important. A lot of ways people think about it, just the new one over the old one, new over old. All right, now our scale factor is 3/4. So what I can do is I can set up a proportion and say, well, whatever this ratio is, x needs to be a number that works out to 3/4. All right, so what I can do here is I can cross multiply. 2 times 3, which is 6. 4 times x, which is 4x. Then I solve this equation. Divide by 4, divide by 4. So x would equal 1.5 units, or in this case, feet. So over here, this is 1.5 feet. All right, and then I just go about it the same way for all the rest. Let's do these two sides because they're the same, 3 feet and 3 feet. So let's say this is y and also going to be y. All right, so first set up a ratio with these corresponding sides, new over old. So y over 3 equals my scale factor of 3/4. Cross multiply. 3 times 3, that's 9. 4 times y, that's 4y. Divide both sides by 4. And this would turn out to be 2 and a remainder of 1, so 2 1/4. So y on both of these, is 2, let's call it 2.25 feet, 2 1/4. All right, and then of course we do the same thing for the last one. Let's call this side z. So I would do z over 4 equals 3/4. Cross multiply. 12 equals 4z. Divide by 4. Z equals 3. So z is 3 feet. All right, and so that's how you would use the idea of scale factor and similarity to find all the missing sides of our smaller reduction here. All right, let's take a look at number 4. Number 4, the following figures are similar. If A is 95 degrees, which I'm going to label right here, B is 85 degrees, C is 90 degrees, and D is 90 degrees, find the corresponding measurements over here. And so like we talked about, similarity between shapes is all about same shape, just not same size. So as far as the shape goes, these corners have to have the same shape, which means that the measurements have to be the same as well. So hopefully this was an easy one for you, because all you really needed to do was realize that all the angles should be the same, despite the fact that it's a smaller shape. That W was 95 degrees, X was 85 degrees, and Y and Z, these two corresponding ones, were both 90 and 90. So despite the fact that on number 3, the size of the sides changed, the size of the angles did not. All right, so that's number 4. All right, so let's take a look at an example where we can use all this information. So here I've got two triangles, and it states at the top that these two figures are similar. So I know that they're the same shape, just different sizes. And what we're looking for here is some of the missing information. For example, this side is missing information, and so is this side. And so what we can do is we can put our understanding of similarity to use. So first thing we want to do is we want to take a look and figure out, well, if they're similar triangles, then they have corresponding sides. And so what are those corresponding or matching sides? Well, here I've got a right angle. And so as I can see, they're not in the same place, because I think what's happened here is this triangle's been turned. So they took it and rotated it 90 degrees counterclockwise. So that would mean that the 9 units on this side correspond to the measurement of 12 units on the larger one, which would then mean that this question mark here, which I'll just box it out, should correspond to this 16 units over here. And of course, that means that this 15 units, which I'll circle, corresponds to this missing side here. So what we discovered was that with similar triangles, that all 3 sides, if I pair them up, this one, this pair, and this pair, they should all work out to the same scale factor or ratio. So the first thing I need to do is I need to find the complete set. So here, if I look, the boxed pair, it's not a complete pair of information. We're missing this one. The circled one, we're missing this one. The only one we have a complete information on is this pair, these corresponding sides. And like we've been doing, what we want to do is we're going to make a ratio out of those where I'm going to compare the image to the original. In other words, the new figure over the old figure. So 12 to 9, which if I reduce that down is 4/3. And if I want to go further, that means 1 1/3. So that's the scale factor. This is the scale factor of these two pictures, that this new image is 1 1/3 times larger than the original. And so just something to note, what we did was we did the new figure compared to the old figure. It's something to pay attention to, because if we did it backwards, it would be 3/4, and this is definitely not 3/4 as small as this one. All right, so now how do we use that to find these two pieces? Well, what we can do is we can set up a proportion. Now I'm going to go back a step. I'm going to use the 4/3 because for proportions it's easier if we're using improper fractions and not mixed numbers. But let's say I'm looking for this box set. So, and instead of a question mark, let's call this x. So the way I'd set up that ratio is new figure over the old one, or the image over the pre-image. So it'd be 16 over x. And with similarity, it says that this ratio should be the same as the ratio that we got from the other side, which is 4/3. So I can say, well, 16 over x is equal to 4/3. And these are some pretty nice compatible numbers, so you might have figured it out already. But I'm going to cross multiply to figure it out. So here I get 4x equals 16 times 3, which I believe is 48. Divide both sides by 4. X equals 12. So this side is 12 units long. All right, and now I can do the same thing with our last set. 15 and question mark, we'll call this y. Okay, so new measurement over the old one, so we're going to do y over 15. And that should have the same ratio as this one, 4/3. So compare that to 4/3, set up a proportion, and then solve. So again, cross multiply. We get 3y equals 15 times 4, which I believe is 60. Divide by 3. Y equals 20. So that means this one has a measurement of 20 units. And of course, we're imagining that this all didn't take place on graph paper, because we could have just counted the squares. So without the graph paper behind it, this would be the way we would use similarity to our advantage to find missing information about two similar figures.